Radioactivity. In this topic, we are going to study definition of terms used, types of radiations, half-life, nuclear equations, quantitative determination of fusion and fission, importances of radioactivity, pollution effects of radioactivity. In our previous lessons, you will remember that chemical reactions take place by use of the outermost electrons of an element. However, chemical reactions are different from nuclear reactions in the sense that chemical reactions involve the electrons, while nuclear reactions involve the particles of the nucleus. Nucleus has got the protons and the neutrons. The neutrons are electrically neutral, while protons are positively charged. The number of protons and neutrons are collectively called the nucleons, and they are found in the nucleus. They determine the mass of an atom. Protons plus neutrons gives us the mass numbers. Some atoms have different masses but have the same number of protons. They are referred to as isotopes. Isotopes are hence atoms that have the same number of protons but different number of neutrons. And since protons equals the atomic number, then this gives us the proton number as the same as atomic numbers. Isotopes that are unstable, or those that emit radiations or particles, are referred to as radioactive isotopes. Radioactive isotopes are also called radioisotopes. And since we are involving the nucleus, the particles in the center of our atom, they are called radioactive nuclides. Simply, radionuclides. Examples of isotopes include normal hydrogen, written the mass number as 1 and the proton number as 1. The proton equals 1, the neutrons equals 0, hence the mass is 1. Deuterium, or hydrogen 2, has a proton number of 1 and a number of neutrons as 1, giving us the mass of the atom as 2. The heavy hydrogen, or what is referred to as tritium, with a mass number of 3, obtained by adding the number of protons 1 plus the number of neutrons 2, giving us 3. Other isotopic elements include the carbon, carbon 14, carbon 13, and carbon 12. with respective masses as 14, 13, and 12 respectively. The number of protons are the same for all of them, but the number of neutrons differ. Nucleides whose the number of protons and neutrons have a ratio of 1:1 are said to be stable. Those whose number of protons to number of neutrons, the ratio of P to N is not equal to 1. In other words, either protons are more than the neutrons or the neutrons are more than the protons, are said to be unstable. Unstable nucleides achieve stability by the spontaneous emission of radiations, and this disputes excess energy. A lot of energy is released. As they achieve stability, the nucleides disintegrate into more stable nucleides. An example is the heavy hydrogen. With a mass of 3 and the number of protons as 1, meaning the number of neutrons is 2. And therefore the ratio of P to N equals 1:2. And therefore this nucleide is unstable. In its disintegration process to attain stability, it loses a particle, an electron. And this electron, 3 minus 0, we get 3, 1 minus minus 1, minus minus 1, which changes to 1 minus, this changes to positive 1, we get 2. And that the atom whose nucleus has 2 protons is a helium. And therefore, on losing that particle, it gains stability. Some of the disintegration processes take longer than others. Some take seconds, others take hours, others take days, others take weeks, while others take years. And therefore, some nucleides take longer to change than others. And that is why some of them will be found in one's own lifetime. When this process is studied, then this is what we refer to as radioactivity. The property possessed by these unstable nucleides of some elements, e.g. uranium and carbon, they are therefore isotopic and they are radioactive elements. By definition, therefore, radioactivity is the spontaneous emission of particles, the alpha particles, the beta particles, the neutrons, or the radiations referred to as gamma or the K capture.